All right, hey guys, welcome to 3.3, and we're looking at the final section of hydrocarbons. Okay, and we've looked at part A, we've looked at part B, now we're looking at part C. Okay, now there's going to be a little bit of content that I'll go through that does connect to the past two videos as well. This won't be a long one. Let's get straight into it. So we've looked at alkanes. We've looked at alkenes. We've looked at alkynes. And we've looked briefly at haloalkenes. Or alkanes, sorry. Now, their functional group, Fg, looks like the following. For alkanes, it's R and H, where H will just be a hydrocarbon chain, okay? And an example of that can be C, H, 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 and H, which is methane, okay? There's our R section, all right? And there's the hydrogen there, okay? The next one's alkenes, all right? Which would look like this. C, C, and we're just going to call this R1, R2, R3, and R4. Now those R groups can change as well, but a lot of the time they're carbons and hydrogens. And here, the example I'm going to provide is ethene, okay? Okay, where R's are just hydrogens as well. Okay. Going on to alkynes, we've got a carbon with a triple bond to another carbon, and we've got R and R. We'll call that R1, R2, and there for this example goes C, H, and H. Okay? And that can be longer as well. I'm just doing the example to be pretty simple and small. All right. Now then, haloalkenes, we've got an R group, and we've got the X. Now the X is your halogen. Okay. All right. So I'll provide an example here where there's C, C, H, 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 and we're going to go Cl up here. Oops. Let's just erase that and put that as R. And we've got Cl, which is there. Okay. Now with a haloalkene, the main thing to see is that there is a halogen, all right, attached to a carbon with a hydrocarbon attached to that. All right. Okay. Now the next one we will look at today is alcohols, and we will need to know how to name an alcohol when we see it in a chain as well. But that will look such as follow. R, which represents a hydrocarbon chain, and OH. Okay, so let's have a look at an example. C, OH, and then we draw across the hydrogens. So, OH is there, OH is there. Now, the two molecules to find out that it's an alcohol is oxygen and hydrogen bonded together, okay? And then there are a few others as well. We do have now in stage, other functional groups will be covered a lot more in stage 2, which is year 12. And you'll encounter more of these in year 12. It's just to sort of open you up to seeing what these are from year 11. Okay, the next one is an aldehyde. All right, we've got R, C, double bond O, and then an H. All right, and an example of that will be C, C, and then double bond O, H. Okay, where you can see that there is the same as that there. All right, you'll next have a ketone. Just change that one there. Where there's R1, C, double bond O, R2. All right, and we can show this as C there. C, double bond O, C, H, H, and H. Okay, and where's that? Whoops, where's that? It's right there. Okay. The next one is a carboxylic acid. Oh. All right. R1, C, double bond O, OH, C, okay. Similar to aldehyde in a way, but instead of that carbon being bound to an O, bound to a H, you've got OH this time. All right. Then we have a ester. All right. R1, C, double bond O, O, and then R2. All right. Amine, RNH2, and amide, RC, double bond O, NH2 as well, and they are all the functional groups that you'll look at a little bit in year 11 and a little bit in majority in year 12 as well. Now, in terms of study for the exam, you will need to know how to name and draw out an alcohol, which we'll look at next. Okay. All right. So looking at the following drawn out alcohol, I'll just call this naming an alcohol. All right. I'm just going to draw it as the skeletal formula or the structural formula or the skeletal formula, and then I'll just expand that out as well. So we've got OH, all right. And what I'll do here on top of that, I'm going to just put the carbons in yellow. All right. And then in red, I'm just going to put my hydrogens next to that. Okay, so here we go. That carbon is bound twice. So how many hydrogens would it be able to bind to? 2. So we'll call that CH2. This carbon's bound 3 times. So how many hydrogens can it have there? 1. CH2, it's only bound once. CH3, H2, H2, H3. Okay, now, this is the process about naming it, okay? We need to firstly identify the longest carbon chain containing the hydroxyl group, okay? And we can see, and I'm just going to do another color, we can see that it is, if we go let's go green this time, we can see that it is this chain here, okay? Now, we wouldn't go this way, all right? We would not go that way. Now, as we can see, that doesn't directly contain, let's just do this. That doesn't directly contain that OH, okay? So I'm just going to highlight that in a different color. So red doesn't directly contain OH. It sort of chains off in a way. It's a side chain. It's not on the containing chain with the hydroxyl group. Okay, we can't look at the side chain. Okay, so we got to look at the one in green. All right, and we start from the OH, and we count across. Okay, and when we count across, we see how many carbons there are to know what name it is. Okay, so here we go. So we've got 1, 2, 3, 4, and 5. All right. So what we know that it is a pent. It would have pent in its name. All right. Now there's no double bonds in the structure, so it's not pentene or pentane. We've got an OH here. All right. It's an alcohol. So what would the name of it be? Well, it's a pent 1-ol. Now, that's great. That's the name of the chain. But the thing is, I need to take into account this side chain. All right, looking at this side chain, from there, how many are coming off it? And we can see that there's 1, 2. All right, if there's 2, remember, we need to name what one it's on. It's on 2. So 2-ethyl pent 1-ol. Okay. Now, why does the 1 come out? Well, it's because it's bound to the first carbon. Why is 2-ethyl there? Well, that's because from this second carbon, we can see there's a 2-chain carbon there, which is why it's called 2-ethyl. All right. Bit of a tricky one, that one. We'll go for something like sort of simpler. Well, we'll go for something a lot simpler, and then we'll go for a trickier one after this. All right, so here we go. We're going to go across this time, and it's going to go as follows. So here we go. All right, now draw in your carbons. 3, 4, 5, 6, 7, 8. All right, and now we will draw in the hydrogens. So that'd be a H2, 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 H2. Okay, and then we are going to start where the OH is, but instead of counting this way, we're actually going to count that away. All right, so going across, you can see that's 1, 2, 3, 4, 5, 6, 7, 8. All right, now what would the name be? It would be a oct 1-ol. All right, and that would be the name of this chain here. Now, this is the harder one, if I had, one coming off here, and that was a CH3, and another one coming off here, and that was a CH3, well, the names would be like this, all right? So it'd be 3, 6 methyl oct1ol, all right? And that's the name of that. You wouldn't have it as 3-methyl, 6-methyl oct1ol. No, you've 3, 6 methyl oct1ol. All right, that's it for today. You're going to have to practice a lot on this with those questions from 14 onwards. All right, and good luck.